Alright, so this discussion is about greatest integer function, which you would have seen is written like this. And we know the value of a greatest integer function. I'm assuming you understand it, but if you don't, I'll briefly explain you what a greater integer function is. The topic is we're going to calculate the limit of a greatest integer function. Okay, this is what we're trying to find out. But before that, we will just briefly understand. So a greatest integer function is equal to the greatest integer function on the left of x. So for example, if you take x to be 2.3, so I say, okay, greatest integer function of 2.3. Okay, so it has two parts. One is 2 plus 0.3, right? And if you see the number line, and this is your 0, this is 1, 2, and this is 3, then this is 2.3. And the number on the left of 2.3 is 2. So the whole number to the left of 2.3 is called as the greatest integer function. And the balance is called as the fractional part, okay? Fractional part. So the greatest integer function for 2.3 becomes 2. And the greatest integer function of an integer itself is the same integer. No change. Now assume negative side minus 4.9. Let's draw a number line and say this is 0, minus 1, minus 2, this is minus 3, minus 4, and minus 5. So we are referring to minus 4.9. So on the left of 4.9, the greatest integer is minus 5. So answer is minus 5. So this is some basic information about greatest integer function. This is not the focus of the discussion today. The focus of discussion is limit of greatest integer function. Okay. Now let's say you have this greatest integer function and we want to find the limit. Okay. Let me do one thing, and you will face this situation in JEE mains quite often and JEE advanced also. Now the strategy that needs to be applied to calculate the limit of greatest integer function, in any question you see a greatest integer function, there are two things that need to come in your mind. One, whether the limit or whatever, maybe derivative is being found out. So I can change the question and say, okay, let's find the derivative of a greatest integer function. Irrespective whether you're finding derivative or limit, once you look at the greatest integer function, you have to find its whatever you're doing, derivative or limit, at two places. One, at all integers. Okay, so x is only integer, and the second is when x is not an integer, which means it's real, but for example it is between two integers. A value of 2.3 is a non-integer value, but a value of 2 is an integer value. So you have to find 2, 3, 4, minus 2, minus 3. If you find the greatest integer function here and then at non-integers, that's the way you need to approach this question. So let's start the question. If a function has a limit, then the left hand limit has to be equal to the right hand limit. Now in the case of greatest integer function, the first step is always to take an integer itself. Okay, so if I find the left hand limit of a greatest integer function at some integer n, for example, right, I will write it as x tends to n minus h, because I'm finding the left hand limit, and h is tending to 0, and then I write it as n tending, right, n minus h is and h is tending to 0, right, n is tending to 0. Now we know we have reduced the number by some quantity, so the answer is n, right, n minus 1. For example, this was an integer I took to start with. I started with the first case, which is integers. So I am finding the limit when x is an integer, and let's say I started with a simple one, 2. So 2 minus h, a very small value, would be 2 minus 0.1, 1.9, and 1.9 greatest integer function will be 1. So this is 2 minus 1 is equal to 1. Now let me calculate the right hand limit when x is an integer. Okay, now x is an integer, but say 2. So we will find the limit of x tending right hand limit for the greatest integer function. So this is limit x tending to, so h tending to 0, and this is 2 plus h is equal to, so 0, and if you put the value 2 point maybe 0.01, very small value, h tending to 0, so you will get the answer as 2. So do you see the left hand limit came out to be 1 and the right hand limit is coming out to be 2. So at integers, okay, at integers, the limit of the greatest integer function does not exist, and you can try this for any number of integers, say minus or positive, it doesn't matter. Now this concept is very important to understand, because if you don't learn this, you will constantly spend countless hours understanding the concept from here and there, and but this is the crux of the greatest integer function. Lot of is this used in calculus, and most of the students don't know how to approach a greatest integer function for the purpose of limit or purpose of integration or for the purpose of derivative. So I thought I'll just make this video and clear it today. Now let's see another situation. Okay, situation number 2 is when the x is a non-integer. Okay, now x, for example, is 2.3. okay, now when I do this and I take it as 2.3, say x is a non-integer, but the limit is x is tending to that non-integer value, okay, and say 2.3 minus h, right, a very small number gets subtracted from h is tending to 0. The answer to this comes out to be an integer which is 2.3 minus h and limit of h tending to 0. So h is very small, so this will become 2. Okay, so the left hand limit for x being a non-integer is coming out to be 2. Now let's say you are calculating when limit is to be calculated at x tending to 2.3 plus h. Okay, so let's do that. 2.3 plus h, and h is tending to 0. Now I'm calculating the right hand limit when x is a non-integer. So this is, this is 2.3 plus some minor decimal number, so the answer is 2. So do you see, when it's a non-integer situation, the limit does exist and comes out to be equal. So for a greatest integer function, the conclusion is the limit does not exist if x is any integer. Okay, and the limit is the integer itself, right? So I took the integer part of the overall non-integer. So if it is 2.3, the 2 is the full part and 0.3 is the fractional part, and see the answer is 2 in both the cases, left hand limit and right hand limit, right? So the integer function, the full part of it will be the limit. So the limit does exist, right, and it is equal to the greatest integer function, maybe n, if you don't want to write it as x because it will confuse you. X is divided into a full number and a fractional number. So this is your answer, right? N. The n is your fractional, the full part. So limit does exist for a non-integer situation and is equal to the greatest integer closest to that non-integer. I hope this is clear, right? So limit does not exist if x is an integer, but the limit exists and is the greatest integer closest to the point at which you're trying to find the limit. So thank you very much for your time. I will come out with some more videos on the concept of limit, and please do spread this. A lot of students I teach face this problem that they don't understand the greatest integer function. So the greatest integer function is definitely a step function, and you can draw those graphs and stuff like that, but then what is the question. You have to finally learn them also, how to use them in derivative, limit and integration, and this video tells you the two ways you have to look at an integer function to solve any question. So thank you very much and wait for my next video.